Hey guys, in this video we'll be looking at isomers of alkenes. So we're going to go through structural isomerism, we're going to look at chain isomers and position isomers. Let's go. So what are isomers in the first place? Isomers are molecules that have the same molecular formula, which means the number of atoms of each element are the same. But they have a different structural formula. They are arranged differently in the 3D space. Let's start by looking at all the isomers of pentene. When we want to identify the name of an isomer, the first thing that we need to look at is the functional group. So when we look at this molecule, we can clearly see that there is a carbon-carbon double bond, and this is the functional group of this molecule. Therefore, this molecule will belong to the class of alkenes. Now when we want to look at which isomer of the alkene this is, it is important for us to identify the position of the functional group. So the first thing that we do here is label the carbon. Here we can start from the left or the right. So we will have 1, 2, 3, 4, 5. So we are going to number the carbon. And then we can also start from the right. 1, 2, 3, 4, 5. Now, why is this so? When we are learning this topic, we have to remember that although they are two-dimensional on paper, they are in fact 3D structures. So let's say I have this pen. Whether I hold this pen this way with the tip facing here, or whether I hold the pen this way with the tip facing this side, it is still the same pen. Now this is the simple concept that we are going to apply here. So here you must always start counting from both ends of the chain. And then which number do we choose? So we look at the carbon where the CC double bond starts. So carbon starts from carbon number 1 here when we are counting from the left. When we are counting from the right, it starts at carbon number 4. So which do we choose? We always choose the smaller number. So this is 1. Therefore, we can ignore this numbering. So we have chosen the yellow numbering. We are following the yellow numbering because the carbon number is smaller where the CC double bond starts. So this will be known as pent. Why do we say pent? Because there are 5 carbons in this chain. Pent is the prefix for 5 carbons. And then we go on to write the position of the CC double bond. So here the position of CC double bond is at carbon 1. So this will be 1. And then we end with what type of molecule this is. Since this is an alkene, it will be -ene. This is the suffix. So this molecule is known as pent-1-ene. Let's look at another molecule. Here we do the same thing. We have 1, 2, 3, 4, 5. And then we always start from the other side as well. 1, 2, 3, 4, 5. Now we have to look for the functional group. Here the functional group is the CC double bond. So we are going to see which carbon numbering are we going to choose. Here, if we start from the left, it is number 4. If we start from the right, it is number 1. And we will always choose the smaller number. Therefore, we are going to ignore the yellow numbering. We are going to follow the blue numbering. So again, this molecule has 5 carbons. So we start with pent. And then the position of the CC double bond is at position number 1. So this is 1. And since this is an alkene, we will end with -ene. So this is pent-1-ene as well. So this is actually exactly the same molecule as before. Let's compare them. This is what I mean by whether we hold the pen this way or whether we hold the pen this way, it is still the same pen. This is the same with this molecule. Both are pent-1-ene. So whenever we number the carbon, we must always try from both sides. Let's go to the second isomer of pentene. Here we do the same thing again. We start from the left. 1, 2, 3, 4, 5, and then we start from the right. 1, 2, 3, 4, 5. In this case, we have a CC double bond, and the position of the CC double bond, if we start from the left, is 2. If we start from the right, is 3. So of course, we're going to choose 2, and so we ignore the blue numbering. This is again a 5 carbon molecule, so we start with pent. The position of the CC double bond is now at carbon number 2. So this will be pent 2, since it is an alkene, ene. So this is called pentene. As we go on from here, I will recommend that you pause the video and try to name the molecule yourself before I go through it with you. So you would be tempted to think that this is actually pent3ene, but there is no such thing. Let's see why. So again, we start the numbering 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. So here again, let's look at the CC double bond. So if we count it from the left, this would be 3. If we count it from the right, it would be 2. And we are going to choose the smaller number. So this will be eliminated. And this would in fact also be pent, because we have 5 carbons. 2 for the position of the CC double bond and ene for alkene. So this is actually also pent2ene. There is no such thing as pent3ene. So far, we've covered 2 isomers of pentene. Let's see the difference in these isomers. Their molecular formula is the same. Both have 5 carbon atoms and 10 hydrogen atoms. So both have a molecular formula of C5H10. However, you can see that their functional groups have different positions. So one is at the 1 position, the other is at the 2 position. These are known as position isomers. Now let's go to the third isomer of pentene. You will notice that this molecule is a bit different from the 2 molecules we did earlier, because now you can see it is no longer just a single chain. You can see that something is sticking out of the main chain. This is called a chain isomer. When we have chain isomers, the first thing we need to do is to identify the longest chain with the functional group. This is the first step. How do we do that? So let's look at how many chains we can form from here. This can be a long chain. So when we say longest chain, what we mean is carbon atoms connected next to each other. They form one chain. So how this works is, let's look at this wire. So if we hold this wire straight like this, it is one chain. But if I bend the wire this way, it is still one chain. It is still a single chain. If I bend it here, it is still one chain. It is still the same chain. This is the concept that we are using here. So we are looking for the longest chain. Here, this is one chain. We have 4 carbons. We also have another chain. We can start from here and go up. So remember, it doesn't matter if it is bent. This is also a single chain because the carbon atoms are connected side by side. And then there is actually another chain. We can also look at this. This is another chain. So we have 2 chains with 4 carbons and 1 chain with 3 carbons. So we take the longest chain, which means we can eliminate the 3 carbon. So we only focus on the chains with 4 carbons. Which chain do we choose here? You have to remember the chain has to include the functional group. So the chain that includes the functional group, which is also the longest chain, is the pink chain. So we are going to look at the pink chain. This will be our base molecule. So what is our base molecule? Our base is, this has 4 carbons, therefore it is a bute. Now let's find out the position of the CC double bond. So we have 1, 2, 3, 4, and if we count from the other side, 1, 2, 3, 4. Here the position of the CC double bond is either at 1 or 3. And of course we are going to choose 1, so we can ignore the blue numbering. This would be then bute 1 ene. This is the base molecule, the longest chain with the functional group. So what do we do about this? Now, this is known as the branch chain. The branch chain is actually an alkyl group. The naming of the alkyl group depends on the number of carbons in the alkyl group. So in this case, we only have 1 carbon. 1 carbon, the prefix in organic chemistry is meth. So we have methyl. This is actually a methyl group. Use the prefix and add YL at the back. So this is a methyl bute 1 ene. But it doesn't stop there because we also have to identify the position of the chain. Now the position of the chain will follow the numbering that we set earlier for the position of the functional group. It doesn't change. Once you have set the numbering for the functional group, we use that for the chain as well. You cannot use two different numbering. It doesn't matter whether the chain is at a smaller position if you count from the other side. So in this case, we already set it to be 2. Therefore, since the methyl group is attached to carbon 2, this will be 2-methyl-but-1-ene. Let's go on to the fourth isomer of pentene. Again, we can see that this is a chain isomer because you can see something sticking out of a chain. So we have a branch here. When we have a branch, the first thing we have to do is identify the longest chain with the functional group. The functional group here is the CC double bond, and so this would be the longest chain. This is the base molecule. Let's number our carbon. Again, we do from left and right. 1, 2, 3, 4, and then we have 1, 2, 3, and 4. And so we choose either 1 or 3. We are definitely taking 1, so we can ignore this numbering. And so now we have our base molecule. This base molecule will be called but because the longest chain has 4 carbons. So this is but. And the position of the CC double bond is at carbon 1. So this will be 1-ene because it is a CC double bond, it's an alkene, so but-1-ene. And then we have to look at the chain again. So here we have the branch chain, and this is a methyl group again because we only have 1 carbon in the branch chain. Therefore, this will be methyl-but-1-ene. Then we need to identify the position of the methyl group. The methyl group is at carbon 3. So this is what I meant earlier. Even though 2 is the smaller number, we ignore 2 because we have already decided the numbering on the carbon based on the functional group. The functional group numbering comes first. Once that is set, it doesn't change. So this will be 3-methyl. 3-methyl-but-1-ene. Let's go to the fifth isomer of pentene. Again, I recommend that you pause the video and try to name this yourself before I go through it with you. Let's see if we got the longest chain right. So the longest chain here can either be, we start from the left, it can be this carbon chain. This is only 3 carbons. What it cannot be is this, because this would not be the longest chain. This carbon is still connected to this carbon, so the chain would continue. So that would not be the longest chain. Instead, this would be the longest chain. And then we can form another chain here, that is here, this one. So which do we choose? Now, we have to choose the longest chain, which is the 4 carbon chain, and it has to contain the functional group. So definitely pink chain is out. It is between the blue and the green chain. So which chain can we use here? It doesn't matter. Both are actually the same thing. Let's use this chain. Now when we use this chain, again, this is a 4 carbon chain. Therefore, the base would be but. Now we have to identify the position of the functional group. So again, 1, 2, 3, 4, and from the other side, 1, 2, 3, 4. So when we look at this, it is either 2 or 2. So you can see it is the same either way. But we have to choose wisely here based on the branch. So when you have the same position for the functional group, then you have to look at the branch. Now the branch here is coming out of this carbon. If the branch is coming out of this carbon, we want the smaller number. So we will take the yellow numbering instead of the blue. So we will ignore this. So now we are ready to go with but-2-ene. Once again, we have to look at the branch. This is a methyl branch again, and this methyl branch is located at the second position. So this will be methyl and 2-methyl. This is 2-methyl-but-2-ene. Let's try to figure out some more complex molecules. Let's try naming this. Again, it might seem that the longest chain here is this with the functional group. But that would actually be wrong because this is not the longest chain. there is another chain that can be formed like this. This is the longest chain. We can actually form another chain here, and that is this chain. This chain has 4 carbons as well. However, it does not contain the functional group. It does not contain the CC double bond. Therefore, we cannot choose the green chain. So we are going to use the blue chain. Now we number our carbons as usual. We start from both ends. So 1, 2, 3, 4. And then we could also go 1, 2, 3, 4. So the CC double bond, the position is either at 1 or 3. We are definitely choosing 1. So we can ignore the yellow numbering. Here the base molecule has 4 carbons. So this is a bute. And the position of the CC double bond is at position number 1. So this is a bute 1 in. Now what about the branch? The branch here is a methyl group at the second position. So this would be a 2-methyl bute 1-ene. Let's look at this one. Here again, let's look for the longest chain. So the longest chain could either be, this is a straight chain, or it could be this one here. This one has 5. So again, we need to be careful. Here we have one chain with 5 carbon and one chain with 4 carbon. But the chain with 5 carbon, even though it is longer, it does not contain the functional group, and therefore we cannot use it as the longest chain. We need to find the longest chain with the functional group, which is the chain that contains the CC double bond. So in this case, that's actually another chain, and that is this, the green chain. So the green chain and the pink chain are actually the same. So we can choose either one. So for simplicity, let's choose the pink chain. Again, number of carbons. So we have 1, 2, 3, 4, or it could go 1, 2, 3, 4. Now, once again, the position of the CC double bond is either at 3 or 1. We are definitely going with 1, and therefore we would ignore the yellow numbering. Base molecule has 4 carbons. So again, this is a bute. The position of the CC double bond is at 1, so this is a bute 1-ene. And then we go to the alkyl chain. So this alkyl chain this time has 2 carbons. So 2 carbon prefix is eth. So we add the YL at the back, this will become ethyl. This is an ethyl bute 1-ene. Now the position of the ethyl group is at carbon number 2. Therefore, this would be 2-ethyl bute 1-ene. When we look at this molecule, we can form several chains. You can form this chain with the functional group. You could also form this chain with the functional group. Now these two chains are in fact the same thing. So I'm going to use the pink color one. Here you will notice that we have 2 branches instead of 1. So let's go with the base name first. Again, choose the numbering 1, 2, 3, 4 or 1, 2, 3, 4. Here the position of the CC double bond is either at 2 or 2. They are the same position. When they are the same position, we have to look at the branches. The branches are also at 2 and 2. So here it really doesn't matter which we use. So let's just use from the left. The base is bute because there's 4 carbons in the longest chain, and then the position of the CC double bond is at carbon number 2. So this will be a bute 2-ene because the double bond is present as the functional group. Then we go to the branches. We have 2 branches here. Both are methyl branches because they only have 1 carbon. So this is methyl and this is methyl. Now we have to look at the position. So when we have 2 methyl groups, first of all, we must call it a dimethyl. When there are 3, we call it tri. So this is 2, we call it dimethyl. Now we have to look at the position of the methyl groups. So they are at position 2 and 3. Therefore, we have 2, 3. So when we are separating the numbers, we use commas, and then dash dimethyl bute 2-ene. So this is a 2,3 dimethyl bute 2-ene. What if the branches were on the same carbon? Let's look at this molecule. The longest chain would be this. So let's name this 1, 2, 3, 4 or 1, 2, 3, 4. We would be choosing either 1 or 3. We are going with 1 since it is smaller. So this would be, the base has 4 carbons, so but. Position of the CC double bond is at 1, but 1 in. Let's look at the branches. So we have one branch here, we have a metal branch here, we have another metal branch here. So again, we have 2 metal branches, therefore it must be dimetal. So this is a dimetal but 1 in. Now you would notice that both of them are at carbon with position 3. So how do we do this? This would be 3, 3. You have to write 3 twice. 3, 3, dimethyl but 1 in. If you've learned something from this video, guys, please do me a favor and hit that like button. It really does help. Thank you very much for doing that. If you have any questions, you could ask them in the comments below. I will do my best to answer you as soon as possible. If you enjoy videos like this, do subscribe. I will produce at least one video a week. I'll see you in the next video.